Okay, so here's one complete row unit for this TwinRow planter that we're building. Kind of go over some of the key components of this thing and what makes it work, or at least the thought process. Haven't tried it yet, but so essentially we started with an XP row unit and then just mutilated it. Basically what we did is we split the rear shank from the bulkhead, or some people call them the uprights. That's this piece here, and there we put in, there's a nut I don't need anymore. There we put in a splitter. We'll see that made here later in the video. And basically what that does is it bolts to the bulkhead here, and then, well, splits the row unit into two. We have shank number 1 and shank number 2 there on the far side, 8 3/4 on center. And there's a reason that I had to go a 1/4 inch wider. We'll see that momentarily. So now what that does is it gets the rows basically perpendicular to one another. Makes it a lot easier to time these row units so that the seed drops one and then the other. Kind of go into the old 2-cylinder concept, right? I think what I'm going to call this project, kind of been thinking about it as I'm building it, I'm going to call it the synchro seed, right? Yeah, it needs a little more work, but kind of an homage to the old synchro range transmissions back in the day. But I don't know. Things you think about as you're out here in the shop. So anyway, that's how we got this thing started. So that gets us the 2 row units. The row units themselves are just John Deere XP cast iron units. Nothing special there. Well, way better than the Great Plains ever was. We'll put it that way. It's coming around here to the back side. You can see they do have the E-set upgrade. That does make them a little narrower up top, so that helps. Plus, I mean, E-sets, right? Can't go wrong. Right in there is why I needed to do 8 3/4, and that's because of that gearbox right in there, and hitting the other row unit. Honestly, a 1/4 inch, that corn head ain't gonna know the difference, I don't think. Also, these vacuum domes, John Deere makes a narrow variant of the original vacuum dome. These are for TwinRows. John Deere does make some TwinRow options. However, they're on 38-inch centers. They're for the pumpkin, or not pumpkins. I think peanuts is the other thing that's really grown in TwinRows. So that's the lower end. We'll get to the fertilizers in a moment here, but you're probably wondering what's this contraption, and I don't know. I don't think I posted it yet, and if I haven't, I apologize. With the way this season's been, from an accounting standpoint, to the way harvest went, to, oh yeah, I picked up more ground, to basically trying to get all my cover crops in, I can't remember what I posted and what I haven't. If I haven't, I'll post it with this video. But I made an entrainer adapter for that air cart back there, for a Kinze entrainer. So that adapter plate mounts to the bottom of that air cart, and those entrainers only have 12 lines, meaning they can only service 12 rows. Now, I thought about using the front and rear compartments, but with the capacity in that thing, you would have to start dividing boxes. No, we're not doing that. Plus the added weight of the tanks, we're just going to keep it at one box, the rear that is, and I forget exactly how many bushels are in that rear. I do know it's larger than even a 1790s central fill system, so we're going to be fine with one box. But anyway, back to the entrainer. That only has 12 lines. We need 24 because this is going to be a 12-row twin row. That means there's going to be 24 individual row units such as that. So what I had to do is come up with a way to split that airflow from each of those entrainer channels to service 2 row units. Now the way that works is you have an air pressure source over here that blows out to diffusers like this. So when those diffusers open up, because the seed is low, air moves. With the movement of the air from that high pressure source, it grabs some seed and carries that seed along to where it is needed. Great. So what does that have to do with that still? Well, that is just an old John Deere diffuser. It's a mini hopper off of just a regular XP meter housing. So what happens is it fills this up. This is where the air pressure stops, and then it just gravity feeds down through here. You'll see this in this video as well. This is nothing more than, well, some very interesting welding done late at night, but it's just a splitter. I took a pattern for an exhaust splitter and just welded it together, I guess, off of that pattern. I had some pipe laying around in the scrap bin. I found these elbows online. They're just cold rolled steel, so nothing special. Again, just they're weldable. So I welded one end onto that plate, the other end onto that little splitter. We'll see that in this video being made. And then from there, it just comes down, gravity feeds these 2 row units. And I have already tested that out. That works excellent. So, done. And then, like I said, E-sets. Now, coming further back to how we're going to manage our fertilizer on these row units. I originally thought about the unit mounted fertilizer openers. They would go up front here, and that would mean that I would have 2 of those on a row unit that was originally designed for literally 1 true V opener. It's already trying to provide enough downforce for 2. And I did some reading, and those Martintil UMOs, I guess they call it, they're very good, very well built, but they require down pressure. And since I was already going to be sacrificing some of that, I did more research. Came across these. These were made by, I believe it's Hawkins. Found these on Marketplace, of all places. But basically what's nice about these is when you have pressure from the ground, as these try to penetrate, you have force going up like this here at the back. And what that does is, right here's your spring. So when that pushes up like this, right here's your fulcrum, and it actually pushes down right here. So now it's pushing down right here on my seed opener, pushing up back here on the fertilizer. If this isn't consistently at 2 inches deep, it's not the end of the world. I'd like it to be, but you know, if it hits a rock or something of that nature, at least it's going to push up like that, push or compress this airbag, transfer the force to this part of the row unit, and push down. Just like that setup a little better. So biggest concern there is up there is the toolbar, all the way back there is going to be the tail end. That's a lot of leverage up there, and with the way these case toolbars are designed, where they raise like this, will it raise it okay? I don't know. There's a lot of unknowns here, but I do know those same lift cylinders can lift 32 row units. I saw well, I guess I should say 31 row units. It was a soybean planter that a guy put splitters on one of those toolbars, and it worked just fine. So, like I said, I'm fairly confident I wouldn't have started this project if not, but there it is, guys. A finished synchro seed row unit. All right, so we have 3 complete row units now on our toolbar, and you may notice that this one is missing something, and it came to my attention after I got this project underway that our friends over at Bauer built. So now we're bringing in a 4th planter manufacturer to this blend abomination, whatever you want to call this project at this point. Our friends over there at Bauer built on those big 48 row planters, those DB, what are they, 120s? Basically anything over 32 rows. They have these little Y fittings that go onto a row unit like this. They're actually, I honestly have no idea how they work. The first time I saw one, I went out to Ag Talk to verify that it's even what they're for. I thought maybe it was like a way to inject a second variety into a row, but you know, like a refuge or something of that nature. But no, it's what they're for. And how it works is, or how it supposedly works, is you put it on one of the rows, the source for that row, and it feeds row number 1 in this case out of the CCS system, and then once this gets full, it blows the seed up straight up at a 90, jumps it over to the adjoining row right here. So that's what we're gonna do going forward. It's a lot easier. It speeds these up. I don't have to weld all of these assemblies, weld this on there, bolt this on. It deletes probably an hour, maybe 2 hours. Yeah, probably about 2 hours from each row assembly. So that'll help us. But now that these things are in the air, you can see how the gearboxes are gonna work. All in all, just how the whole thing will work. So that's where we're at out here now. Let's go up in the shop and see what we're up to today. Okay, so this is what we are going to make in the next part of the video. Bear with me, as well, I made the majority of this piece back in the summertime when I had that cart all torn apart. Biggest reason is this plate right here that adapts to the underside of that cart. Well, I had to access the bottom of that rear bin, and to do that takes time. I had to tear it apart anyway to access the meter housing when we did all of that. So naturally, I just built this piece at that time. So we're going to build this, which is the Kinze entrainer adapter plate. And what this assembly does is it takes high pressure, well, high pressure is a relative term, I guess, pressurized air from the central air cart in on this side, and pressurizes this assembly here. As it does that, seed from the air cart falls into the assembly like this. It comes, well, obviously the thing's upside down, but again, bear with me. The seed falls in from the bulk storage tank here and lands Let's open this up so we can get a better view. Lands on, oh, that sounded fun. Lands on that screened floor right there. So it fills up this little chamber in here, and that pressurized air then comes in through these channels here at the top. As that air does that, it forces the seed up and causes it to percolate, kind of like a coffee maker. Let's see if I can't get this back on here. There we go. And as that percolates, make sure we don't break anything when it's cold. As that percolates, that seed will then blow out these individual holes here. So with this entrainer, we have 12 channels. I already went over with you out there our new method as far as dividing the seed flow from each of these 12 channels to the 24 rows that are out there on the planter. And yeah, this is our assembly. So without further ado, let's get started and see what kind of assembly we made and how we accomplished mounting a Kinze product to a John Deere labeled flex coil product. This sounds interesting. All right, boys and girls, it's time to play some connect dots. Doesn't this bring back memories of, I don't know, preschool? Definitely a fire drill right there. Wash, rinse, repeat. All right, phase one of our entrainer adapter plate is complete. This is the part that'll mount just like this. That way's the front, towards the front of the cart rather. It'll mount just like this up to the bottom, and our other adapter plate will be down here. Now that adapter plate is going to hold yet another adapter plate. We'll get to that in a moment. But right now, that's where we're at. So we got that all torched out, ready to go. Let's go look at this other adapter plate. That's right here. Here's our other 1/4-inch plate that we're going to drill out and then machine out. That'll ultimately weld on to the bottom of that one that we just looked at. And this is our Kinze adapter plate, literally from the man himself, John Kinzenbaugh. All right, there you can see Kinze and the part number. This used to mount to the bottom of those big plastic Kinze central fill tanks. So that went on there and then funneled it down into the actual entrainer, which was right here. Now I suppose I could have simplified things a little bit by making this mount directly to the entrainer. I'm just not going to. One, for a couple of reasons. We got a nice funnel here on the Kinze plate. See how it funnels like that right up into the smaller opening? Definitely like that concept a little better. And number two, why? This is so much easier just to drill these bigger holes, and this already has the nice seal on it. It's just ready to rock. Plus we need to drop this down as far as we can. So to get it below our other manifold there, which is right now just hanging there in the service position, or whatever Flex Coil calls it. So that's where we're at right now. I'm gonna go ahead and drill those other holes. Nothing too exciting there. I'll go ahead and torch that out, and then I'll check back in with you when we're ready to kind of weld these two together. All right, so we got the other adapter plate all torched out now. And now the next step, which as you can see, I've already took the liberty of chopping up this this 1/4 inch piece of flat shot. I think that's 1/4 inch by 3. Got that all hacked up on the bandsaw to basically make standoffs between the bottom adapter plate, which mounts to the Kinze entrainer adapter plate, which is what you see right here, and the top adapter plate, which is that thing right there on the ground, that'll ultimately mount to the bottom of the air cart. Is this making sense yet? Yeah, I don't know. I keep telling myself that it does. So it's got to, right? Maybe? I don't know. Let's weld. Welding's fun. Most of the time, anyway. So we got that all tacked up. I don't know if you can see it from up there, but